Hey guys, what's going on? It's Lester again. So today we're going to take a look at our ATR-6, our traction relay valves, which is also a relay valve. It's in the same family as the R12 and the R14 valve and pretty much performs the exact same function, except for now we've added this control solenoid. So let's talk about that a little bit. So this is the thing. When we have an ABS event and we see our modulators, or you may not know this is a modulator, but if you've been going to the class, you should know. So we see our modulator valves right here. And we understand that when we are having a ABS event, that normally we're going to be pushing down on our pedal, and then the ABS computer is going to be pulsating our modulator valve to ensure that we don't have wheel lock. So building on that, when we have a traction control event, we may or may not have our foot on the brake. And if we don't have our foot on the brake, which is totally normal, think about it, we're driving down the street, all of a sudden I hit a patch of ice. My foot is just not immediately going to be on the brake. It's going to take me some time to get my foot over to the brake. So in that, soon as the computer detects the wheel slip, then the traction control portion of the computer is going to be able to do something to help us keep control of that vehicle. But understanding that in a pneumatic system, we have to have a way to electronically get air into this modulator valve so that the computer can start to use the modulator valves to control the wheel slip. And that's basically what this solenoid is going to do. So we see that we have that same line. So let's trace this line right here. So let's look at this smaller orange line, and we're going to trace it back. So we go back, right here, boom. And then where is it going? Right down into our foot valve, right? So think about it. Normally, I'm going to get air when I press on the pedal, on my brake pedal. I'm going to get my control or my signal air from here into my control port, and then I'm going to have the actuation or the relay piston is going to move down, and then I'm going to have air go through my modulator and then go into my brake cans, right? But in a traction control event, how is that going to happen? I don't have my foot on the brake pedal. So now what's going to happen if we look right here, we see this larger orange line, and let's trace this back. Where before, so let's stop right here at the treadle for a second. Where before, when we looked at older systems, we had 100% of our air for our, sorry about that. We had 100% of our air for our front brakes come straight from the treadle and then actuate our front brakes. Now, if we look at this port on the treadle, we'll see that it's plumbed right here, and let's continue to trace this line back. So we go back through this air manifold, and remember this is a mock-up, so this is here for mock-up purposes. But we trace this line back here, and then where do we see it? We see that the line that we have, basically this is a supply line from our secondary air tank. So understanding, we have secondary air pressure present right here. Okay, so right here, coming through this line, and then into our ATR-6 relay valve. And so inside of this valve, there is a drilled passage, and that drilled passage leads up to this control solenoid. And basically what this control solenoid is doing, it has a spring loaded, and it's holding a check valve in place that is making sure that air can't just come up into the relay. So when we have a traction control event, the ECU is going to send a signal to the solenoid. It's going to energize the solenoid and move that spring back, which is going to allow that check valve to open up. And then we're going to have 100% air application from our secondary tank to push down on our piston, and then allow our modulators to have air so they can begin to work. So we'll talk about the actual modulator and how it works in a different video. But basically, the first thing we had to do is say, well, how are we going to be able to get air to our modulator valves for them to work? And that is happening because of this control solenoid right here. So after we understand, after we get air to our modulator valves, then we can use a pulse width modulated signal or some sort of signal to actuate our modulator valves. And that's pretty much it. There is no real difference in if we're not having an ABS or a traction control event, this valve is not going to act any different from our R12 or R14 valves. Now, the thing is, whereas I've read that some the biggest difference of the R12 and R14s are in the lid, this is in the same family, but it is a kind of completely different valve. It's the same theory of operation, but the valve is I shouldn't say a whole lot different, but it is significantly different on the inside. So we'll talk about modulators in our next video, and I think the video after that will cover the anti-compounding features of the R12 valve. All right, hope this helps you guys. Have a nice day. Bye.